So what if I told you that the lightning-fast, highly responsive engine that's basically powering almost every modern web app you use today was actually born out of a desperate attempt to fix PHP?
I mean, it sounds completely absurd, right? But it's true.
Yeah, welcome to the deep dive. Whether you're, prepping for a major engineering meeting, or maybe you're just trying to decipher all the front-end jargon your dev team throws around, or honestly, if you're just insanely curious about how the digital world actually functions, you are in the right place.
Definitely. And, our mission today is to completely decode React.
Right, exactly. We're going to totally bypass the dry code syntax. Like, we're not doing that today. Instead, we're going to focus on the architecture, distilling this massive topic down into clear aha moments for you.
Yeah, and that origin story you just mentioned, that is the perfect place to start. Because React, which is this absolute powerhouse JavaScript library for building user interfaces, it started in a totally different ecosystem.
It really is a phenomenal paradox. I mean, to truly understand why React works the way it does today, you have to look at the massive bottleneck Facebook hit around, what, 2010?
Yeah, 2010, exactly. They were dealing with an infrastructure largely built on PHP, and they had created this clever extension called XHP.
SHP, right?
Yeah, and its primary goal was to allow developers to write custom, reusable, like HTML-like elements directly inside PHP. But its superpower was actually security.
Okay, wait, security, how so?
So it automatically neutralized cross-site scripting attacks. Like if a malicious user tried to inject dangerous code into a comment or a message, XHP would basically sanitize it before it ever rendered.
Oh, wow. So is it like an automatic filter?
Exactly. And it was highly successful at keeping the platform secure.
Well, I mean, security is great, obviously, but XHP lived strictly on the server,
Yeah,
right?
entirely server-side.
So if you were building a highly interactive, dynamic web application, you were essentially tied to a tether. Like you click a button, a request travels all the way to the server recalculates the page, and then sends the whole thing back.
Yeah, and making even a tiny microscopic change to the user interface meant the entire page had to re-render.
I always think it helps to think of this old server-side model like having to completely demolish and rebuild your entire house just because you wanted to change a single light bulb in the kitchen.
That is exactly it. And that is computationally exhausting, bandwidth heavy, and just incredibly slow for the user.
I can imagine.
Yeah, I mean, when you're a company trying to build a live, dynamically updating news feed where people are constantly liking, commenting, and sharing in real time, that full house demolition approach is a dead end.
Right. The browser just couldn't handle the constant tearing down and rebuilding of the DOM, right? The document object model.
Precisely. So the problem was super clear. The server round trips were just killing performance.
Which leads directly to 2011 when a software engineer named Jordan Walk built a prototype called